So hello everyone, today we'll be solving this problem from SPOJ. So the problem statement states that Anjali and Nakul are good friends. They both had a quarrel recently while playing chess. Nakul wants to know the minimum number of moves a knight takes to reach from one square to another square of a chessboard of size 8 cross 8. Nakul is brilliant. He had already written a program to solve the problem. Nakul wants to know whether Anjali can do it. Anjali is very weak in programming, so we need to help her. So as we know, knight can move in 8 directions. So let's say that this dot is our knight and it currently has x comma y as coordinates its current position. So the knight can move all the way in this way or this way, this or this. So these are the ways the knight can move. This would be x plus 2, this would be x minus 2, this would be y plus 2, this would be y minus 2, this would be x minus 1, this would be x plus 1, this would be y minus 1, this would be y minus 1, this would be y plus 1, this would be y plus 1, this would be x plus 1, this would be x minus 1. So these are all the 8 directions we can traverse. So the clear idea says that we need to do a traversal and this is a grid. So can we ideate that it's a graph traversal? Probably. Forgetting we have a BFS tag here. Yeah, so it's basically a graph traversal problem. So why only BFS? We can also do DFS too. But the problem is that if it's a very critical position where it requires really lot of moves, DFS wouldn't be an ideal one. Or to extend the problem, if it's not an 8 cross 8 chessboard, it's a n cross n chessboard and n is a quite large value. In that case, we cannot just do DFS. That would incur a lot of memory and time as well. So to begin with coding this, so according to the problem statement, we'll be given test cases. So we have taken the test cases. So after taking test cases, we will be given two strings. I would name it initial, I, and goal as G. Now, there's a problem with the string. They are in the chess notation like A1, H8, etc. So the first letter in both of them would be an alphabet. So I need to basically convert it into a zero-based indexing. So I would take initial x equal to I of 0. So can you tell me how to convert a character into zero-based indexing? Just subtract ASCII value of A from it and it would be converted into a zero indexing. Why? If I of 0 equal to 0 and ASCII value, if I of 0 equal to A, then ASCII value of A minus ASCII value of A would give you 0, and if it's B, B minus A would give you 1, and so on. So in IY equal to, IY would be a number that's in the form of a character. So I of 1, first thing I would do is subtracting 0 from it. That would change it into a number. Now I have a number that's 1 based indexing. I need to convert into 0 based indexing. So I would do a minus 1. The same thing I would do for my goal as well. So this would be gx, this would be gy, and this would be g, this would be g as well. So yeah, we have done the zero-based indexing now. And I would like to print the output that I would obtain from the BFS that I would do later. I would pass ix, iy, gx, and gy. And I will be writing the code for BFS. It would return an integer minimum moves. So yeah, this is our BFS function. I would like to check for an edge case if this itself is the goal node. I would directly return a 0. I'm currently standing at ixIy. If ixIy is itself gxgy, then I need not make any moves. I would directly return a 0. So after this, I would like to traverse in some dx directions. And I would also like to traverse dy directions. So now what are dx and dy here? Let's see. we can see all these directions we are traversing are of the form x plus dx and y plus dy. That's very clear. So dy equal to x, dy equal to 2 has two dy combinations, minus 1 and 1, and minus 2 has combinations minus 1 and 1, minus 2 has combinations minus 1 and 1, and plus 2 has combinations minus 1 and 1. So yeah, we will be writing all these 8 combinations in dx dy. So I would quickly write it up for you. So I have written all the dx dy combinations: 2 with 1, 2 with minus 1, minus 2 with 1, minus 2 with minus 1, 1 with 2, 1 with minus 2, and minus 1 with 2, minus 1 with minus 2. And this seems pretty clear. Next, to initiate the BFS, I would need a visited array that would be of Boolean type. And here, this would be of size 8. Sorry, this is vector bool. Yeah, okay. And as we know, the BFS algorithm requires a queue. Now here, usually if the node is an integer, we will have an integer. But if the node is a character, we will have a character. Here our node is a cell, the cell of the chessboard. So it would be a custom one, a custom data type structure cell. It would be having my current x value, it would be having my y value, x and y coordinates. Along with this, I would like to store the number of moves also. So when we are at a position x comma y, on which move are we at? We will be storing that too. So this would be of type cell. And I would be pushing my initial node into the queue. Before that, I will mark this as visited, since the initial x and initial y node is visited. Initial x, initial y equal to true. So we have marked it as visited. After this, we would be pushing it into the queue. So I would push ix, iy. So what's our current move status? We haven't made a move yet, so it's 0. And while queue is not empty, my current cell would be my front of the queue, and I would pop this front. So I can move in 8 directions. So my new x would be my current x plus dx of y, and my new y would be my current y plus dy of y. After computing this new x and new y, I need to check if they are within the bounds. I need to check if they are within the bounds. So I will declare a Boolean function that I would name is safe. If it's out of bounds, then it's pretty obvious that it's not safe to go. I would check if an integer x and y go out of bounds or not. So I would return to say that x and y are in bounds. X must be greater than or equal to 0, and x should be less than 8. And y should be greater than or equal to 0, and y should be less than 8. In this case, we can say it's not out of bounds. I missed the semicolon here. So yeah, if my new x and new y, if my new x and new y are not out of bounds, hence they are safe, and I haven't visited them yet. I haven't visited my new x, new y yet. The standard BFS thing. In that case, okay, so if it's safe and it's not visited, then I can push them into the queue, right? I can push them into the queue. I can push new x, new y, and my current moves plus 1 to the queue. Since I'm obtaining a new x, new y and visiting them, that means I'm making a new move. So that move would be added to the current number of moves. So current moves plus 1. But I will do this only when if it's not the goal node itself or the goal cell itself. So I would have an extra check if nx is the gx and ny is gy. In that case, I can directly make a move In that case, I can make a move and return it. That would be my minimum number of moves. So in other cases, I would push it to the queue, and before pushing, I would mark them as visited in x and y equal to true. So I would mark them as visited and push them to the queue. Perfect. And the BFS will do its work. That's pretty obvious. If I don't find a possibility that the moves can be done to reach the goal cell, I would return a -1. So let's check if our code is all right. We have a cell, we have a bool save function. The BFS logic seems pretty right. So yeah, let's try submitting this. But yeah, I forgot to take the input of I and G. So let me take it first. Then are there any such other errors that we have done? Let's see. No, right? Code seems pretty right. I would test it locally, then I would submit it. So let's try to submit this here. You just solve minimum right moves problem, okay? That's fine. So yeah, this got accepted.